Hi guys, so this is going to be how to draw isolines A. So what I've done is I've opened up the PDF file ES Notes 203A Isomap A, and you can see that up here. There's the title right there. All right, so this activity, I think we all got a chance to do this in class for this. So this should be review, but I'm going to go through it just like it's brand new for those people who didn't get a chance to see it. So this is Earth Science Connect the Dots, and we call this drawing isolines. An isoline is a line that connects points of equal value. So instead of going like back in elementary school, going 1, 2, 3, 4, we're going to go 2, 2, 2, 2. So we're going to connect the dots, the values that are equal, that are the same. So we're going to start off on this field. A field is an area that we are paying attention to and we're ignoring everything else. So this area is our field, and on this field we have multiple measurements. So all of these dots represent actual observed locations where somebody went out with an instrument and made a measurement of some kind and recorded the value of that measurement. What we're going to do is we're going to organize and classify this data by drawing lines on here to connect the points of equal value. So when we do this, we do it by an interval or a counting number. So according to the directions, we're going to do an interval of 2 on this one. So I'm going to start off with the value of 2. And I see right away that there is a 2 here and a 2 here. So at some point, I've got to connect these both with some kind of line, with an isoline. But we don't only have observed 2's or measured 2's on the field, we also have inferred 2's. So if I were to think about a number line, such as 1 to 5, if I count off 1 to 5, 1, 2, 3, 4, 5, there is a 2 in between 1 and 5. So here I have a 1 and here I have a 5. And if I were to, again, apply that idea of the number line, I would have a 2, a 3, and a 4 in between those. So I can guess that the 2 is probably about right here. So not only are there observed and measured 2's, there's also invisible inferred 2's. So we have to consider those as well. Our ISO line is going to connect all of these 2's, whether they be measured and observed or inferred. All right, so to do this, I'm going to get rid of some of this blue ink. All right, so what I'm going to do is I'm going to start off and I'm going to take a look at these 2's that are up here. And in between there, I have a 1 and a 4. And if I imagine my number line between 1 and 4, there's going to be a 2 between them. So I am going to be able to go between those 2 dots to connect the 2's. But I can infer that the 2 is likely going to be a little closer to the 1. So instead of just drawing a straight line, I'm going to draw kind of a curved line that goes from the 2 to the other 2. And that suggests that there is an inferred 2 right there in between the 1 and the 4. All right, so first rule of isolines is that they connect points of the same value. That's what iso means. The second rule of isolines is that they cannot stop in the middle of the field. They have to either go off the field at the margin, or they have to loop back and connect with themselves. So in this particular case, I have 2 ends. I've got to figure out where they go. So I'm going to start with this end over here. I've got to continue it somewhere. So what I want to do is I want to take a look at the surrounding numbers. So there's a 4 and a 5 here. Is there a 2 between 4 and 5? There is not. So I can't go in that direction. I can consider that blocked off. Can I go between 1 and 1? Well, there's no 2 between 1 and 1, so I can also consider that blocked off. Is there a 2 between 1 and 5? Yes. All right. So the 2 is likely to be closer to the 1. So I can think of the 2. I can think of my line following 2's closer to the 1, not going near the 1, but closer to it. And now I can extend it down. I don't draw any of this other blues. Those are just for discussion purposes. All right. So looking around at the other dots now I can say, okay, well, where can I go? Can I go between a 3 and a 5? There is no 2 between a 3 and a 5. Can I go between a 1 and a 3? Yes, I can. So I'm going to take and continue my line downwards until I'm about halfway between. And there's no other inferred twos down here in the corner. So at this point, what I'm going to do is I'm going to just take my line and kind of take it over to the margin. And when it gets to the margin, I want to label it. All right, so one end of my line has now gone off the map. Now I have to go back up to the other end and continue the other end. Since one end has gone off the map at the margin, I've got to take the other end off the map at a different margin. So I've got to go some direction. Can I go between 4 and 4? No, I cannot. So I can think of this as being walled off. Well, if I can't go through there, can I go up? Can I go between 1 and 4? The answer is yes. And so what I'm going to do is I'm going to take my line and I'm going to go up and go off the margin up here, and I will label it. So now I have my 2 line complete. There are no other 2's that I can see and no other places where I might be able to infer a 2. Now, if you have any extra marks, if it's not clean, you probably want to try to clean it up a little bit. So I'm going to do that. All right, that might be kind of tricky with your finger if you're using a mouse, or the best thing to use on this one is a stylus. So this is where you can go to mom and dad and say, hey, look, a stylus is really helpful right now. Okay, so continuing. So we're going to go by an interval of 2. We have the 2 line done. So since we're counting by 2's, our next one would be 4. So right away, I can see that I have a 4 here and a 4 here. So the next rule of isolines is that all the isolines, they cannot touch and they cannot cross. And because of that, they're going to follow a similar pattern. So I kind of got 3 things there. Number 1, they cannot touch. Number 2, they cannot cross. And number 3, they follow in a similar pattern. All right. So I'm going to be connecting these 4's eventually. I just want to confirm, can I go between a 2 and a 10? Is there a 4 between there? So 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, there's a 4 in between there. It's probably going to be a little closer to the 2. So what I want to do here is I want to draw a line that's going to connect these 4's, but it's going to follow the same pattern, the bend in the 2 line. So instead of just going a straight line from 4 to 4, what I'm going to do is I'm going to kind of create a curve that is similar to the curve in the 2 line. All right, I'm going to get rid of these blue marks. All right, so now I have a 4 line, but it's ending in the middle of the field. It can't do that. Again, one of the rules is it has to go off the margins, or it has to loop loop back on itself. So I have to continue these ends. Now this end up here is so close to the margin, and there's nothing else that's telling me that something is happening. So I'm going to take that and take it off the margin up at the top. All right. So now I have to do the bottom of the line. So going down, I know that it's going to do something like the 2 line is. So it's going to end up somewhere down here. I just don't know exactly where. So what I need to do is I need to follow the numbers carefully. Can I go between a 5 and a 7? No. So I can't go here. Can I go between a 7 and a 9? No, can't go there. Can I go between a 1 and a 5? Yes. Even though the 2 line is already going through there, there's plenty of room for the 4 line as well. So I'm going to take my line and I'm going to bring that down. I'm going to go between the 1 and the 5. All right, so now can I go between this 3 and this 5? Yes. So I'm going to continue down. And then can I go between this 3 and this 5? Yes. So I'm going to clean that up a little bit. Bring that down, and I'm getting close to the margin. I can't go between 5 and 5, so I'm not going to go off to the right. There's no information to the left that suggests that it's going to bend out to the left. So what I'm going to do is I'm going to just bring that straight down and go to the margin, and I'll call it there and label it with a 4. All right, so now I'm done with the 4 line. Again, these 2 lines are following a similar pattern. They don't have to be identical. They don't have to be parallel, but they're doing something similar. Okay, so our next line is a 6 line. So if you look carefully, there are no observed 6's. There are no actual measurements of a 6, but that doesn't necessarily mean that there aren't invisible 6's on here. So the next step is to figure out where there are some inferred 6's. Now, before we do that, I want to explore the idea of what an isoline is. An isoline is a line that connects points of equal value. So if I draw an X on this point right here, what would be the value of that point X? The value would be 4 because it's on the 4 line. By drawing the line, we are telling the audience, the readers, that point, any point on that line is going to be equal to a 4. Now that's an inference, it's not an observation because it's an educated guess based on those observations and the patterns that exist. But we are saying we're making the decision that that point is going to be a 4, and we drew the 4 line there. But now I can use that point as a 4, and I can use that with a combination of any of the other points to help me figure out where the 6 is. So is there a 6 between 4 and 10? Yes, there is. So somewhere about maybe right there is going to be a 6. Is there a 4 between 4 and 9? Yes. All right. So there's going to be, again, a 6, maybe 5, 6, 7, 8. So maybe right there. There's going to be a 6 between 5 and 7, right in the middle. Another 6 between this 5 and this 7, right in the middle. And there's going to be a 6 between this 5 and this 7 down here near the bottom. So now I've got a whole bunch of inferred 6s. I could even go up here and do this one. 4, 6, 4, 6, 8, 10. So maybe right here. And so now I can start seeing how the line is going to get drawn. So I'm going to start up here at the margin. I'm just going to go down and connect into all of these dots that I've identified as inferred 6s. Now, one thing you want to do is you want to make sure that this is relatively neat, which I know can be challenging. Using a mouse or even a stylus or your finger. So you definitely want to kind of go back and clean some things up if you can, so that generally speaking, it looks nice and neat. All right. So once it goes off the margins, I need to label it. And so now I'm done with the 6th line. So again, to review, the 6th line is connecting all of the points, whether they be observed or inferred, and it is not touching or crossing the other 2 lines, and therefore it's going to follow those lines in the same general pattern, the same general movement, and they're going off the margins or connecting in a loop. Okay, so we're up to 8. So there are 2 8s, and they're relatively close together. So to be real honest, I can pretty much connect those with just an easy, simple line. Now I got to figure out where to go. So there's nothing down here on the right-hand corner to tell me that where I should go. So, and the pattern of the 6 is just to kind of curve down a little bit. So I'm going to do that. I'm just going to curve this down, and where it goes to the margin, I'm going to label it. Going up, I can look at the pattern that's in the 6 and the 4 and the 2, and I can kind of decide that it's going to do something where it's going to kind of curve over to the left and then go up. So I know where to look. So is there an 8 between 7 and 9? Yes. So I can bring my line up to here. And then another 7 and the same 9, so up to here. Is there an 8 between 9 and 10? No. So I cannot go between these 2 points. I have to go on the inside of them. Now again, I can assume that any point on an existing line is the value of that line. So I can say that there's a 6 here and that there's a 6 here. And that will help me identify that there's going to be an 8 between the 6 and the 9. So I can take this and I can continue up and bring it to the margin up at the top and label it with an 8. All right. Next is the 10. So again, I'm going to have to follow the same general pattern. I have 2 10s that are very close together. So I'm going to connect those with a line. I need to continue upwards. I've got nothing up here to tell me what's going on, so I can just kind of continue that up to the margin. Same kind of thing that the 2, 4, and 6, and 8 are doing. I'm going to label it at the top. Then I'm going to take the line and bring it down. There's going to be a 10 about halfway between the 9 and the 11, so I'm going to bring this down like this. And then there's nothing else out here to tell me where to go. So at this point, I'm just going to kind of follow along with the 8 and follow that same general pattern. There's my 10 line. Okay, so we're going by an interval of 2. We're counting by 2s. So we have 2, 4, 6, 8, 10. Our next one is 12, and we do actually have a single 12. Now, it's almost impossible to infer where there are other 12s based on the observed points. There aren't any 13s, so we really have a hard time figuring out where there might be any inferred invisible 12s. So we really don't have any more observable data to base our line off of. But I do have an existing pattern. I do have the pattern that we can see in the other lines. So what I can do is I can draw a line that's going to go through the 12 that will fit with that same general pattern. So what I'm going to do is I'm going to come in off the margin. I'm going to go in and hit the 12, and then I'm going to come back out, and there I go. Okay, so I'm now done with this, this map A. And just to review the rules, so an isoline connects points, both observed and inferred, of the same value. That's what the prefix iso means. Isolines cannot touch, they cannot cross, and because of that, they're going to follow the same general pattern. Isolines have to go off the map or they have to loop. Now, in this case, all of the isolines went off the map. None of them looped. We're going to see that in a different example. Where they go off the loop, we should label them. And a last note is isolines have to go by a counting number called an interval. In this case, it was 2. If anybody has any questions on this map, please email me about it. What you should do now is you should try recreating this. Refer back to the video if you want. Refer back to this diagram if you want. But from this video, you should be able to draw the 6 isolines that are on this map. And if you have trouble, make sure you go back and see why it was drawn the way that it was drawn. Again, if you have any questions, send me an email.